Hello guys, and welcome to our YouTube channel. So in this YouTube channel we are going to go through Young's double slit experiment, and this is an example I used. So I have two basic examples for you, so we are going to go through it. But how is the experiment? Well, he just arranged two slits like this. The slits are just the openings, as you can see. This is the first and this is the second. So when he incident light source through, this is the screen, here is the screen. So if he incident a monochromatic light source, that is a light source with a single wavelength, then when the plane waves of the light source arrive at S1, that is the slit, there will be what? At S1 there will be a diffraction that will make it to go this way, and at S2 there will also be another diffraction that will make it to go this way, and from there we'll be having constructive and destructive interference. So when constructive interference occurs, you will see a bright fringe on the screen. It will be indicated by a bright fringe, and they will appear in the pattern like this. At the center, the bright fringe is at maximum, then it keeps dying, the amplitude, and like that. So we are having at the center, it is at maximum, like this. So we are having this one to be So we're having here is a dark spot, here's a bright spot, here's a dark spot, here's a bright spot, here's a dark spot, here's a bright spot, and so on. So that's what you will see on the screen, a series of black and dark spots, and this is resulting due to interference, that is the superposition of the waves. As this one is being diffracted as it passes through the aperture, the other one too is being diffracted. So when they meet constructively, they will give constructive interference. A bright fringe indicates that, and when they meet destructively, they will give destructive interference, and a dark spot appears on the screen. And now this spot occur here. We have m equals to 0, that is the where we have the maximum bright fringe, because this one is traveling a distance, let us say 2 wavelength, this one is traveling same distance 2 wavelength. When they meet it, they will give it will be more brighter at the center. So, and for up here, it will be something like this. This one will travel maybe 3 wavelengths, this one will travel 1, 2, 3, and 4. So this one will travel 4 wavelengths, something like that. The one down will travel a longer distance, so there will be a difference of a single wavelength, right? Okay, now from there we can come up with our formulas that we need to use. And by the way, before we continue, we'll say that this is the first order bright equals 0. The second, where we have the next bright fringe, is here. So we'll be having m equals to 1. The next way we have the bright fringe, m equals to 2. And down here we have m equals to -1, m equals to -2, and m equals to 3, and so on. But for the odd, we are having m is half, 3 on 2, 5 on 2, 7 on 2. In fact, all the odds, we are having -1/2, -3 on 2, -5 on 2, and so on. So that is where you have the destructive interference, where m is having those numbers that are fractions, -1 and 2, all the odd fractions of 2. Okay, that is it. So if the first light is going, you will be having a difference with a wavelength. So let us say if this is the wavelength that they are having a difference, and this is the angle it is making with the first bright fringe, the angle from the center to there, we have the angle that it makes with the center, the first bright fringe mixed with the 0 maxima, where we are having the 0 order, right? We are having the more bright fringe here. So the angle is θ1. From there, if the difference between the two wavelengths, if this one travels 3, this one travels 4, so it will be a single wavelength. And by trigonometry, and we have here theta. And by the way, we will need the distance between the two slits. The distance between the two slits is also needed. So the distance between the two slits from there to there is needed, and is called d. So we see that d will be the hypotenuse, and from there we can use trigonometry, that sin theta equals to lambda on d, right? And we can say d, I'm talking of θ1, so sin theta will be lambda on d, so I can say d sin θ1 is equals to lambda. And I'm associating this angle with the first bright fringe after the center, right? That is m equals to 1. So if I'm talking of m equals to 2 or m equals to 3, then this formula will have what m here. That it depends on which order are we talking about. So that's the first formula you will find. Create more space. So that is the first formula that you will find under this Young's double slit experiment. And the next formula is simply knowing that the distance between the slit and the screen is L. The distance between the slit and the screen is L. Let me use a different color for that. Is L. Then we have, let us say, the distance from the 0 to the first bright fringe, we call it Y1. This one. From 0 to the second, we call it Y2. From 0 to the third, we call it Y3. So from there we can see that we'll be having a certain triangle of this manner, something like this. So we're having Y1, we're having L, and we're having theta 1. So I can see that tan theta 1 is equals to Y1 on L, right? So we can say tan theta M, where M can be 1, 0, 2, 3, and so on, will be equals to YM on L. And these are the formula that you need, the second formula. And when theta always approaches 0, sin theta is always equals to tan theta when theta is very, very small. So from there we can see that m lambda over g, by making sin theta the subject here, will be equals to tan theta, which is ym over L. And from there we can have a nice expression that L m lambda on g is equals to ym, or I can say Lm lambda is equals to g ym. So these are the three formulas that you need. This is the first, the one for tan, the one for d sin theta equals to m lambda, and the one when theta is very, very small. So with this in mind, we can go ahead and solve the problems. So the first one, so we can go ahead and solve these problems. That there is some things. So from here we have that sin theta, g sin theta is equals to m lambda, and having tan theta is equals to ym over L, that is tan theta m. You can also put sin theta m equals to m lambda. So I can still say g y mg is equals to lm lambda. So these are the three formulas that you need in this topic. By the way, you not only need it here, you need it in Young's double slit experiment, you need it in single slit experiment, and you also need it in diffraction gratings. So we'll see that in our future videos. So let us go now. We'll now to calculate. They are saying that a first order bright fringe is observed to be an angle of 2.0 degrees when a light with a wavelength of 600 nanometers passes through the two narrow slits. How far apart are the two slits? So we are looking at this distance here. So we are looking for how far apart are the two distance. So we know that g, from equation 1, g will be equals to m lambda on sin theta, and m, we are talking about the first bright fringe, so m will be 1 times lambda, which is 600 times 10 to the negative 9 meters. Please use the matrix unit to convert to the SI unit, not nanometer. You put meters by writing 10 to the negative 9 dividing by sine of 2 degrees. And let me point that, and I got so I had 1.71922 times 10 to the negative 5 meters. So that's the distance I had between the two slits. It is very, very small. I even compared to nanometers. That's maybe 17 nanometers, something, 17 micrometers. Okay, so that is that for the first part. And for the second part, they're saying that what is the distance between the first bright fringe on the screen and the center if the screen is 4.5 meters away from the two slits. So here we are having that our L is 4.5 meters, the distance between the slit and the screen, and we already know our angle theta 1, which is equals to 2 degrees, which is equals to 2 degrees. And from there we can use the second equation, that tan theta 1 will be y1 over L. We are looking back for y1, the distance between the first bright fringe, that is here m equals to 1, and the center at m equals 0. So you'll be having y1 will be equals to L tan theta 1, which will be 4.5 meters into tan 2 degrees. Let me pause the video on pause when I've... Okay, yeah, I got 0.15714 meters, and that is it. And the second problem is saying that a light with a wavelength of 650 nanometers passes through two narrow slits that are 0.05 millimeters apart. If the screen is 8.0 meters away from the slit, what is the distance between the third order bright fringe and the central fringe? So let us try to produce it. Let us try to represent the scenario. We can use our earlier example. So we are having now that it is from the third, that is where m equals 3. So we want to find the distance from the 0 order to the third order. Let us call it y3, right? We call it y3. We know our L, and I've not given you us theta in this case, so we'll use the last formula, that ymd equals to lm lambda, and from there we can see that ymd is equal to lm lambda. We know that ym is what we have to look for, that is y3. What is the distance between the third order bright fringe and the central fringe? So the central fringe is where m equals 0, so y3 will be equals to L m lambda on d, and from there we get our L, which is the length of the screen, which is 8.0 meters, times the order, which is third order. We are talking about the third order, and times the wavelength, which is 650 times 10 to the negative 9 meters. All that we divide by d, which is 0.05 times 10 to the negative 3 times 10 to the negative 3 meters. I converted it. So you just substitute this value and you punch well, you have your answer. Please always keep your answer to 4 decimal places at least. Okay, thanks for watching and have a great day. By the way, please, if you have any word, you can comment, and you can please keep it in the comment section. And we are having groups that will help students around the nation or even across Africa. So you can join and you will say where you have problems, and we will see how to intervene and help you. So you can still screenshot my tutorial. Let me see, started from here. You can take the first screenshot, you can take the second screenshot, you can take the last screenshot. Now like this.